Okay, so I kind of already recorded this video, but because I got a new microphone and my dryer was going behind me, I have to record it again. So last time when we left off, we had created this swipe controller that read the first position that the player touched, the second position where they let off the touch, and then calculated the angle between the two using the arctangent function. So let's talk about what we're going to do next as far as this goes. So if we take a look at our paper here, we're going to essentially use that two-dimensional array that we created in the board class to determine where we need to move and if another piece needs to move. So if we kind of think about our board like this, we've got here, these little dots everywhere, and I'm just going to draw 3 rows just to get my point across. So each of these dots has a column position, so like this is column 0, column 1, column 2, 3, 4, and then this would be 5. I know I have more than 5 columns. And then they have a row position. This is row 0, row 1, row 2. So let's say that we click on this dot right here in the middle, and then we swipe up. What we want to do is we want to find out what this dot is. So we want to find the dot that's at the, I forget what I called that array, dots, has the same column, so 2, and has a row that's +1. We want to make that dot move down, and we want to make our dot move up. So we'll be using this array quite a bit today. So let's take a look at getting this to work. Alright, so in our project here, again, if I hit play, I can have my board be populated with dots, and I turned off the debug statement so it doesn't tell me to swipe anymore. So I'm going to go into my dot class here. So I'm going to open that up in MonoDevelop. So here's what I created last time. I recorded the first touch position, or click in our case. I recorded the final touch position, or click in our case. I calculated the angle between the two, and then I was kind of throwing out whatever that swipe angle was. So what I want to do next is actually move the pieces around, or decide where to go. So I'm going to create another void here, because this doesn't return anything, and I'm going to call this move pieces. It's a little not exactly what's happening here, but we'll get to it. So what we're going to say is if swipe angle is greater than -45 and swipe angle is less than or equal to 45, then we're going to do stuff. So if it's greater than -45 and less than +45, less than or equal to, these two need to be right next to each other, then that means it's a right swipe. So I'm just going to comment this as right swipe. Okay, now there's some stuff that we need to do here. What we need to do is we need to find the board that is to the right of our dot and access its information. So up here in our variables, I'm going to add a couple new variables. First, I'm going to make a reference to this piece's column and row. So I'm going to make this public for debug purposes. So public int column, public int row. And column is really the x position, row is really the y position. I also want to make a reference to the other dot. So I'm going to make this private game object other dot. Okay. And then down here, what I'm going to do, oh yeah, I also need to make a reference to the board script. So I'm going to say private, because I'm going to set this in code, board, and I'll call it board, if I can spell it correctly today. Now once I create this reference, I could make it public and then assign it in the editor, but since our dots are going to be created and destroyed, it's best to assign this in code when the dot is first created. So my start method here is going to say that board is equal to find object of type, and the object we want to find is the board script. I can do it this way because I know there's only ever going to be one board in the room. If there were more than one, then this would be a little more complicated. Okay, so then down here, what I want to do is find So board, actually, let's do that other dot equals board dot all dots. And the dot I want to grab from that, if I'm going to the right, is the one that has a column plus 1. So column plus 1, and the same row that we're on. I want to take that other dot, and I want to get its dot script from it. So other dot get component dot, and I want to change its column to be less than 1. So minus equals 1. And then I want to change our column, so column plus equals 1. So essentially what's happening here is if we're doing a right swipe, we're going to grab the dot that's to the right of us. We're going to grab their dot script and change their column to be 1 less than it was. So if it was 1, it turns into 0, 5 turns into 4, and then turn our column up. Now, this alone doesn't do anything, but what I'm going to do up here is I'm going to create 2 new integers. I'm going to create a public int that I'm going to call target x, and a public int that I'm going to call target y. And the target x and target y are what's going to actually move our piece around. Now I'm going to initialize these in my start method. I'm going to say target x is equal to, we want this to be equal to the x position that the dot is created at, but the x position is stored as a float, so I have to cast it to an integer. So I have to say, as an integer, I want the transform.position.x. I'm going to take this line of code, copy it, and I'll paste it down here. And this is going to be the target y. And that's going to be transform.position.y, casted as an integer. Now, here's where we actually start using that. So here we're just creating these variables. In the update method, I want to say that my target x is equal to the column that this occupies, and my target y is equal to the row that this occupies. And this is going to be the main engine behind moving our pieces around, so that when we change the column of the other piece, we're changing its target x position. And when we change the column of our piece, we're changing its own target x position. Same thing goes for the rows. So down here, I'm going to take that if statement I created, and I'm going to copy it down to here and put it at the end of an else statement so that it's else if now. And I'll do that again because I need to do this for all 4 directions. So 1, 2, 3, 4. Now, if my swipe is greater than positive 45 and less than or equal to positive 135, then it's not a right swipe anymore, it's an up swipe. And the dot that I'm going to get isn't going to be the column extra, it's going to be the same column, but a row up, and then I'm going to take its row and decrease it by 1, and then take our row and increase it by 1. Alright, and then next we want to check to see if the swipe angle is greater than 135, and this one needs to be an OR statement, and I'll explain why in a second. We want to check if it's less than negative 135. So the reason that this one has to be an OR and the rest of these are ANDs is because we're checking if it's greater than 135, if it's on this part of the arc, or less than negative 135. If we did an AND here, it would never return as a left swipe because there's no number that's greater than 135 and less than negative 135. So we'll call this a left swipe. This time we're going to get the column minus 1. We're going to increase that column, and we're going to decrease our column. Now the last one is a down swipe. So for the down swipe, it needs to be less than negative 45, and less than negative 45, and greater than or equal to negative 135. And then that's going to constitute a down swipe. we're going to get the same column, but row minus 1 in this case. And then we're going to change the row of that other piece by moving it up 1, and then move our row down 1. Okay, so there's a couple extra things that we need to do here. First of all, if we're right swiping and we're at the very edge of the board, we don't want to try to find a piece that's past us. So I want to add another condition to this. So I want to say, and the column is less than board.width. If I'm swiping up, I want to make sure that the row is less than board.height. If I'm swiping left, I want to make sure that I'm actually going to put these two things in parentheses because I want it to be that or then a separate and statement. So if it's that or that and column is greater than 0, and then this here, if it's less than negative 45 and greater than negative 135, and this one is going to be row greater than 0. So the reason I'm doing that is because I don't want to be able to have the program looking for something if I'm swiping down on the last row, swiping left on the farthest left column, right on the farthest right column, or up on the farthest up column. Okay, so I'm going to save this. It was a lot of coding, I know. We're going to jump into Unity and take a look at exactly what this does. This isn't going to move the pieces yet, but it lays the groundwork for actually moving them. So if I hit play, here are my pieces. I'm going to choose this one, 0, 0. I'm going to swipe up on it. Now, the reason I did that is if I go choose this piece now, let's try that again. Let's try swiping down on that one. So, okay, so this one thinks it should be at 0, 0. And this one thinks it should be at 0, 0 as well. So there's an issue with that. So let's take a look at my up swipe. Okay, I need to increase my row by 1. Huh. Oh, I didn't actually call the move pieces. So the move pieces function needs to be called after we calculate the angle. So if I go in here, wait for that to compile, and then press play. So I've got this coming up. Again, I'm going to go to the 0, 0, swipe up, and then if I look at the 0, 0 object, it now thinks it should be 0, 1, and the 0, 1 object, okay, interesting. Did I enter that wrong? So this one thinks it should be, let's try another one, let's try over here. So this one now thinks it should be column 0, row 0. That's weird. Let's take a look at this one. Huh. Okay, let's jump back and see what I did wrong. Okay, so here's the problem. I never actually set the column and row. So here, I'm going to say that my row is equal to target X, and my column is equal to target Y, except I've got those backwards again. This should be target Y. Seems like it should be the other way around. It seems like rows should be X's and columns should be Y's. Anyway, I'm going to save this, pop back into Unity, and let it compile for a second. So now that I've got those set, if I go back in here and test it out, I'm going to click somewhere in the editor first just to make sure that it's not registering my first click. As soon as it's done actually playing. Okay, so I'm going to click there, swipe up from 0, 0, and now if I look at the 0, 0 object, it thinks it should be 0, 1. And the 0, 1 object thinks it should be 0, 0. So they know they need to switch places. Now we have to actually make that switching places happen. And we'll do that in the update method. So what we're going to do is I'm going to create another vector 2. And this is going to be a vector 2 that temporarily holds the target position that the dot should move to. So this is going to be private vector 2, and I'm going to call this temp position. Okay, so down here, what I want to do is I want to test to see if my current x position is a certain distance away from my target x position. And if it's more, or if they're not equal to each other, then I want it to move towards that one. Now, since my target x position is based on the column, that's good. But I want to make this simple so that I don't have to test both the left and the right-hand side case. So what I'm going to use is the absolute value, because absolute value is the same no matter which direction you subtract. If you do 10 minus 3, it's 7. 3 minus 10, it's negative 7, but the absolute value of that is still 7. So if I do if, actually using the absolute value, so mathf.ebs, and the absolute value we're checking is target x minus transform.position .x. If this is greater than, say, 0.1, not negative 1, then we want to move towards that. So move towards the target. If it's not that, then we want to directly set the position. So we'll say else directly set the position. Okay, so to move towards the target, what we're going to do is we're going to create that temporary vector, so that temporary position. So temp position is equal to a new vector 2, and this vector 2 is going to be made up out of the target x and the current y position. And then we want to use a movement method called lerp. So we're going to say transform.position is equal to vector2.lerp, and we're going to lerp in between our transform.position, the temp position, and then we have to give it an amount to move every time. I'm going to put that at, say, 0.4 f. Okay, now I'm going to copy this line here. I'm going to set that down there, and I'm going to say our transform.position is just directly equal to the temp position. Alright, so this is movement on the x-axis. So I'm going to save this. I'm going to pop back into Unity. Let that compile for a second. And then I'm going to test the switching left and right here. Ooh, there's another thing that we need to do really, really quickly, but we'll be good. Okay, so now if I hit play, I'm going to let this think for a second, and then when this comes up, we will test out our left and right movement. See if it works, and if it doesn't, totally blame me. I'll see what I did wrong. Alright, I'm going to make this a little bigger so I can see it. And there we go. Oh. Aha! Okay, so we got some problems here. Here's where the problems are coming from. So what we want to do is we want to make sure that after we directly set our position, we also say that board dot all tiles or all dots column row is equal to this game object. So I'm going to save that. Let's pop back into Unity and let's test it out. Still compiling down there, but we'll see. Okay, maybe. I hate having dead air like this. Okay, so flip, 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 flip. And then if I flip this, aha! They're flipping like they should. And if I flip from, get this index out of range, we'll fix that. But now let's do pretty much the same thing for our y position, our target y position. So I'm going to copy this code, make another if statement out of it, and we'll say this is target y is not equal to transform.position.y. Then our temporary position is transform.position.x, comma target y. And then we're going to lerp between these two. And I'm going to copy this line and replace this line. Okay, cool. So let me save, pop back into Unity, and let's take a look. I actually think I know what the problem with that right column was, but we'll fix it next time. This video is already pretty long. Okay, maybe. Come on, Unity. Probably is because my computer's battery's dying and I'm desperately trying to get this done before I have to go plug it in. Okay, so I'm going to hit play. And then when the board comes up, we'll just test out the up and down, left and right movement. Make sure that works and then say goodbye. So up, down, left, right, or right, up, down. Cool. So the next thing we have to do is we have to actually test to make sure that when we get 3 in a row like this, that we declare it a match and then do something. We'll cover that next time. Have a great day. Thank you very much for watching. If you have any questions or comments, please feel free to leave them in the comments below, and I will include my Twitter handle. Have a great day.